Assalamualaikum and very good morning to all. So for today, basically I would like to discuss about the chapter number 3. Okay, so about the linear regression. Okay, regress. Okay, so the one that will be discussed for today is basically related to one variable, or we can call it also as univariate. Okay, so this one, uni means one. Okay, variate mean variable, right? So yesterday we did discuss about things related to machine learning. We have categories, we have classification, and regression. Okay, so this will be under the hood of what they call it supervised. Okay, so unsupervised meaning this one is clustering. Okay, so we have another one is semi, we have reinforced, right? So for today, basically, I would like to focus on this regression. Okay, right. So speaking of the regression, so we did discuss about the kind of definition about regression for during yesterday's class. So what is the one that been stressed during the class yesterday, guys? If I may ask. So let's say we have x and y over here. Okay. So what is x and what is y? So let's say we do have this and this, guys. So what is x? For example, this one is regression. So what is one of the example for regression application? So anyone can help me? So what is y? Any application for regression? Price? House pricing example. Okay. So what is x over here? So basically, in order to fix or to predict the price, we requires the what they call it factor, right? So this one is the layman terms. So in the machine learning stuff, we call it as a feature or attribute, right? So what is the feature for comparing or estimating the house price? So basically, in order to buy something, we need to have what to say, house size. We need to have location, for example. Location doesn't mean that the numerator, right? Size means, example, feet square, and other one could be okay, distance from capital or from city. So that would be one thing to be considered as the feature, right? So in other way around, this is basically for this blue line, blue dots over here. So this one is second one, this one is third, fourth, and fifth. Okay. So the first x1 will be known as this, and second one is this, and so on and so forth. Okay. So there will be things that related to these 5 points over here. So we have this. For example, I just take one. So it could be equal 0.02 and 0.14, for example. So this will be the training data that we have in order to get the regression models. Okay, right? So this one is the training number 1, 2, and 3. So in other words, basically we can make this one as a vector. So either we pull it this way or we pull it that way, vector. So we can say that x1 is in the vector, x2, x3, x4, and x5. Okay, same goes to the y vector. So becoming y. So y1, y2, and etc. So then we have kind of a vector relationship between those things. Okay. So example, if we take a look at this, in order to portray this idea, this line, okay. So we will do have example, z equal what we call it. Normally I think you might know about this. Y mx plus c, right? Okay, right. So what is m and what is c? C is intersection, and while m is the slope, right? Okay, so in this particular discussion, basically this m is probably discussed as weight, okay, Sx plus c is bias. Okay, so z is basically equal to it could be many things that have been done. So for example, this one is known as here, for example, x plus theta 1 and 0, sorry. So this is the intersection, this is the slope, or in the machine learning style they call it weight and bias. Okay, so that will slope in the maths theorem, and that will be intersection in the maths theorem for bias. So that will be the same thing. Okay, right. So that will be the idea of example. So I do have 5 points of training. Okay, then from this particular point of view, basically when I give 2 more, let's say this one is x6, y6. So 2 more data that I want to test my data by using this models regression, right? Okay, this one is x7, y7. So by in order to get this, basically after having a kind of training, okay, sorry, I need to change the color. Okay, after we did the training, for instance, basically we can predict this and that. Okay, by say example for this point we do have, okay, what is the slope over here? 0.2, okay, slope ni 1 lah. X. What is x0, the intersect? Say that's 0. Okay, so this will be the what we call it estimation, or we call it the hypothesis for that matters. So example, x6 is equal to 0.35. Okay, so 0.35 is basically 1 times 0.35 plus 0. So meaning the answer is 0.35 for z. So now z is prediction when we give 0.3. So what is z? 0.35? Okay, 0.35. Alright. So this is basically the estimation, okay, for z using 0.3. But the thing is, when we have the data as a testing data, so we also have the y value, guys. So example, this is 0.4, okay? Example, eh? So the z value is basically estimate, while this one is real value. So in order to find the differentiate, or to find the what do you call it, accuracy for our test. So in order to get in order to see our models is good enough, basically we will find the difference between these two, 0.35 and 4. So that will be the things that will be talked about today as gradient, cost function and gradient issues at the back of this presentation. Okay, right. So the things that we requires over here is basically how many times we train our train data, x1 until x5. So then we gain the hypothesis, but we call it Z. So we gain the theta 1 and theta 0. So this one is for, what is this? Bias. This one is for weight. Okay, weight is equal to slope, while bias is equal to intersection. Right. So based on that Z function, basically we will try to predict the house price based on given new X data. So ke dalam ni. So that is what we call it regression models. Okay. Okay, so this is the real example that we talked about yesterday. Let's say this is house prices, location in Portland. Okay, where's my? Okay, so this is house price in thousands, dollars. So basically, for here, basically this will be 100,000, for example. Okay, so the data has been given for us by features is feet. Okay, feet square. So meaning the idea of having, what is this? Let's say we assume this as 750. So then the data say that the price for this particular feet square is 180K. So that would be the data, guys. Is the same as what we did just now. Here 1, 2, 3, 4, 5. So that's what we call it data. So this is data 1, data 2, data 3, data 4, data 5, 6, 7, and what we call it, every single thing is basically for the data that we have for training. Okay. So the target for this particular graph is to find out the hypothesis of prediction. Says that we will find this one, a line. Let's say this is the line. So meaning by using this line, the new data comes in. Okay, so example, this one, 1,250. So meaning the price is this, based on the regression line that we have from the training perspective. Okay, so then speaking of which, so I think we still remember about the supervised learning. So the thing is supervised meaning we supervise the data, example X, to be Y. Okay, so X2 to be Y2. So this one is, we set the supervised output for X1 to be Y1. Okay, so given the right answer. So this is the right answer, guys, for each example in data. So this one, this is data. This is the right answer. Right. Okay. So regression problem is basically predicting real value. Remember, real value is this one. So what is the value of housing price for given a feature? So the feature could be like the area of the houses, like feet, the distance between the capital to the location of the houses. Example, from the KL to the house, from Seremban to the house. Example, from the Bandar Melaka to the house, and so on and so forth. Right? Okay. So then we talk about model representation. So yes, this is how we do it. Okay. So for example, this is the data in spreadsheet. Okay, so meaning we have column 1 and column 2, we have row 1 and so on and so forth until we got ITH. So this one. Okay, so this is given data. X, as I mentioned earlier, is input. Y is the output. So normally, X will be the x-axis will be the input side, while the vertical one is the price, or what we call it, output. So at the same time, we call it input as a feature, guys. Okay. So not to mention that the features also could be explained as attribute in one's context. Okay. So while the output variable is considered as target, so meaning what is the target of that particular data. So somehow some scholars call it as a target data. Okay. So this is the features. So for that particular cases for I, let's say this is I equal 1, guys. So I equal 1 meaning 2,104, 460 in bracket. Okay. So that would be one training example. So the next one training example is 1416, 232. in K dollars, right? So then we can conclude that all this data is basically in bracket xi, yi depends on this I. So meaning the repetition of the data 0, 1, 0, 2, 3, 4, and etc. Right? So that would be the things regarding to the raw data that we have in hands. Okay. Okay. Speaking of which, the things that I mentioned in the early slides regarding to the data that we have in hands. Hold on. Okay. So now we have this. We have this, right? So x is the input data. So in order to get the y estimate data, basically we need to have hypothesis. Remember about the one that we talk about. A is B, B is C. So conclusion is A is, what is A, guys? What? Yeah, exactly. So this is hypothesis, guys. In order to get this hypothesis, basically we need to have some data, okay, from the top to the bottom. So means we require to have training data the same as what we discussed earlier in this 2104 and so on and so forth, right? Okay, so this hypothesis basically reflected to H function. Okay, this one. So that's the reason why I explained to you in the middle, in the early of the presentation as H function, right? So this, in this particular slide, we assume that this H will be representing a new equation as hypothesis using X and Y data. Okay? So while X is trained, Y is the output target. All right. So in order to do this, as mentioned earlier, previously we call the function as y equal m x plus c, right? Okay. So y is that, x is that, x is here. Okay. So this is slope, while this is intersection, right? So to compare with this one, basically that will be the similar idea I did discuss earlier. So C is this one. So meaning the slope is basically theta 1, guys. And the intercept is basically theta 0, while x is taken from here, the data that we have in hands. Okay, so the data that we have in hands is totally discussed as test data. It's not trained data. So meaning the trained data is being used during the test training sets. Okay, so the training has been given, for example, x1 until x5. So we learn x1 gaining y1, x2 gaining y2, and so on and so forth. Then we have the hypothesis of that particular training data. So we bring the equation of hypothesis, we test with other data. As I mentioned earlier, we test with x6, right? Yeah. Yeah. Kita tak guna data sama over here. So we use other data to confirm that our estimation is good enough or not good enough. Right. So the only parameters in linear regression, okay, now, so speaking of the linear regression right now, is theta. Okay, so either theta is I equal 0 or I equal 1. So for this particular context, so we only have 2 theta. Okay, right. So next question is how we choose this theta value, guys. Okay, so that will be interesting. For example, the question, okay, so this is the true example. Okay, so the choice of theta I, where's my, okay, all right, is made by that h theta x. Okay, so h theta x over here, okay, h theta x over here is this function, guys. So it's similar, goes to when we talk about z equal x b plus a, for example. So this is the slope, this is intersection, and this is the hypothesis, right? It's the same. Okay. The different is only about we change the parameter. So meaning the B now is changed to 0, 1, and this one 0, 0, right? So this one's X is remain, while this one H theta is X. In order to make things function, is dependent on the theta over here, right? So we call it hypothesis function. Okay, example, we have this plus we have, sorry, no. The first one is this, right? Okay, so meaning this one, right? Okay, how about this? So this one we have intersection at 0 and 0.5 could be here. Okay, how about this? 0. How to do this? Is it this? I think here. 0.5. Okay. Which one? Oh, x-axis. This one. Here. The intersections at 1, right? How about the slope? So the slope is. So this is 1, right? So this is 1. This one, right? Passing through 1. So the x-axis is number 2 because the gradient is 0.5, so this will have 1 over 2. Okay, how about this? So this is the intersections passing through the y-axis number 1, right? 1, right? Okay. So this one is 1 over 2. So meaning 0 over 1. Okay. So this is basically the line that has been fixed by given 3 hypotheses, guys. Thank you, right, for the help. Okay. So meaning in order to have this straight line, basically we need to have these 2 parameters, guys. So while this one, in order to have this line, we need to have 2 parameters. So speaking of which, as I mentioned earlier, so basically in order to have that, hold on. So example, the data is here, 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 and here. Example, here, 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 and here. So the data is still the same throughout the graph. But the thing is, so which one do you think is better graph for this data? The same data. So let's assume that this is the length, 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 this is the length. So this is quite narrow, this is quite narrow, but this is far away. This is far away. So meaning, let's say this is 1 cm, 1 cm, 1 cm, 1 cm. This is 2 cm, 1.5, 0, 0. Example, eh? So this one is 3 cm, 3 cm, 0.5, and 0 is 0.5. So which one is better, guys? So based on the first impression, so it's not regarding to the true hypothesis theorem, by the way, but what is the things that happen to be nearer to the line? So this is quite far, right? So this one is quite large. This one also quite large. Okay, but the things is intermediate way to describe the top and bottom is basically this one, right? So because the length from, okay, as I mentioned earlier, this will be the line, right? So this is the real value. So meaning, if we are given 2.5 for x, So the y is 1.5, right? Okay, so 1.5 then. So this one is 1.5. But the thing is, remember the estimate minus the truth. Okay, meaning 1.5, the y is the truth then. So the estimate, the estimate is 1.5 minus the truth is 0.75. So meaning the 0.75 is basically the distance, the true distance between this one. But the thing is, compared to here, so the distance, vertical distance between that point to this line is large. So meaning there will be a huge error, guys, between the estimation and the true data. So you get what I mean? So that would be the things that the next question will be. Now the next question is how to find the theta value, right? So the next one is how to choose the best line instead of having a good theta value. So that would be the two things in linear regression. Okay? Okay, right. So based on the second statement just now, I just put it the second statement to you. So how to choose the best line, slope line. Okay. So the thing is, when we try to find the best one, basically we will need to discuss about the cost function. Okay. So what is the cost function? It is function that measure the performance of machine learning models. Okay. Measure how inaccurate the model in estimating the connection between, okay, remember this one and this one. Okay, what is this? This one is expected loss. And this one is actual. Okay, remember the one that I showed you just now? 1.5 over here is expected or actual. This one. Xiong, can you help me? 1.5 is actual or the estimated or actual? Yes, okay. So 0.75 is the actual one, right? So yes, okay. So meaning to say that we try to measure that how inaccurate. So the more value that we have is basically the more not accurate the model is to that particular data that we give to the model in order to estimate the price, right? So that is what we call it. We require to have the cost function over here. Okay. So let's take a look at one of the most popular cost functions. So obviously we do have not only square error function, but we do have so many more. Okay. Okay. So square meaning obviously this one. Okay, error means, what is error, guys? What is definition of error? So error meaning estimated value minus actual value, right? Okay, that is what we call it error. So this is common sense for every single philosophy or theory in maths and science and technology. So estimate minus actual. So estimate, we knew that we have this. Okay, so actual, we know we do have this. So this is basically error in bracket dash. Okay, so you get what I mean? Right. So to make things happen to be squared is basically we just put it square over there. So meaning what is the most important thing of the square? So why we require to have square, guys? So anyone could help me? What is the reason behind the theme BTS? For having, let's say we have 5 minus 2, we have 3, right? Is that true? Right? Okay. So for example, we do have this one is 5, this is 2. So meaning the difference is 3, right? So now this is 4, this is 0. 4 minus 0 is 4. So we have 4, for example. So the things required to be squared is basically when we talk about two worlds. Example, this is 1, this is minus 3, guys. So what will be? So what is the difference between 1 and minus 3, guys? 1 minus 3. But still okay. So just imagine that the data is plotted to be, let's say, minus 4 and minus 6. Okay, right. So then we talk about minus 6. Minus 4. So what will be the answer? Minus 2, right? Okay, so the distance in that particular context is only 2 steps. Okay, from 1 to each. Okay, but the thing is, in order to avoid this minus, so that's the reason why we put it square. So meaning minus 2 square is 4. So yes, that would be the idea. So then, in order to fulfill the requirement of, I will be not going too deep. So this one is basically requires the m. So square error function, meaning we have SE, right? So normal things happen in square error is mean square error. So mean square error means SE over M. Okay. So this is the mean square error, guys, eventually. Okay. But for the sake of the cost function, the cost function is not MSE, but half of MSE. So that's the reason why we do have 1 over 2 MSE is the difference between this by square over M. So that's the reason why we have 1 over 2M with SE, okay, square error. So then we have this, okay. So then again, in order to get the best line that we discussed earlier, so the one that helped by Go Xiong. So the goal is to find the minimum, guys. So the minimum says that the length from, okay, let's say this one is this one is this one is this. So meaning to say that this one is one thing. Let's say I do draw one line again. So this one is one, this one is the other one. Okay, meaning this line is having more data and more error than this. Why? Because this line, although this looks like similar, but this one happened to be vertical line to the second line is bigger than the first. Okay? So that would be the thing. So meaning, in order to see that the cost function for this particular two lines, so the top one is preferable because they will be having the minimum, the less j error function compared to the first line, right? So that would be the idea of choosing which line is the best for that particular data that we have. All right. Okay, now. So this is the things that happen behind the cost function, if I may say. So remember, the cost function right now is the difference between estimated and what is this value? It's not Xiyong, it actual. Okay, Harris. Real or actual, right? So we do have square them because we try to avoid the minus things that related to the region underneath of this one, right? If happen that we have minus 2 distance, so the distance shouldn't be have the minus sign. Okay. So then we have 1 over 2. Remember, the j is equal to half of MSE. So then now we try to find this function based on this particular given line. All right. So take a look over here. Okay, at first I try to, hold on. I will erase this one first in order to avoid the confusion. Okay, right. Okay, so this given to us for, remember, h theta x is equal h1, sorry. Oh, not this one. Sorry. This one is theta 1. X plus theta 0. Okay? Right. Okay, right. So this one is, hold on, this one is 1, right? Okay. So this is, theta 1 is representing the slope or the intersection, guys. Slope, right? Okay, right. So be careful about this. Imagine that we have j, okay, so this one is j0, theta 0, j0, 1, right? So meaning to say that right now, we have equal 1x plus 0, kan? So this value will be here, and this value will be here, guys. Okay, so how we do it? Okay, basically it just depends on this 1 over 2. So how many data that we have? So this is one data. This is, oh, okay, sorry. Saya tukar hijau lah. Okay, this is data number 1, guys. This is data number 2. This is data number 3, guys. Okay, right. So the data number 1 is located at 1, 1. So the data number 2 is located 2, 2. The data number 3 is located 3, 3, kan? Okay, meaning x1, y1, x2, y2, x3, y3. Okay. So then in order to find the cost function for that particular point, 3 points, basically, okay, now. So this one is x. Okay, h, x, okay. So this one is y. So what is y over here? So this is, okay, real number. So wow, this one is basically hx, okay. What is hx over here? Over here, guys. Okay. So hx is this. Okay, the moment that we have x0, theta 0 is 0, theta 1 is 1. So we have this. Remember? So 1 times 1. So because x is equal to first data, x is 1. So 1 times 1. So the data number 2 is 1 times, what is x over here? 2. Okay. So next one is 1 times x. So what is x over here? 3. So that's the reason why 1, 3. So then we try to sum it 1 minus 1, 1 minus 2, 1 minus 3. So 1 times 1, 1 times 2, 1 times 3. So then again, minus, minus, minus. So we have 0. Okay. So then the answer for this is basically 0, guys. Okay. 0. Okay. Then because of that, 0 is for the function of j theta, j theta 1. Okay. So but the thing is, 1 is taken from theta 1. So where is the theta 1? This value or this value, guys? Theta 1. 0 or 1? 1. So the j, basically, the reason why I put it here, 0, 1, the answer is 0, guys. But when we plot to the graph, is we need to plot theta 1 over here with 0. So what is the theta 1? Theta 1 is 1. So meaning the location for the plotting is 1, 0. So that's the reason why the dot over here in j theta and theta is here, guys. So be careful. So we try to portray the function of y and x in cost function graph. Okay. Oh. Cost, I need to write it slowly. Function. I'm not sure. Is it internet connection? So during not live, so the writing is good, but during the live it's not so good. I just wondering why. Okay. So that will be the first line. Another 10 minutes. Okay, alright. So this is the first line, guys. Okay, now we still use the same data, 1, 1, 2, 2, 3, 3, but we use the different lines, guys. Okay. So now what we have in hands is, so remember, theta 1x plus theta 0, right? So theta 1 is 0.5x plus 0. So that's the reason why here is this one, guys. Where is the 0.5 coming? Basically, 0.5 is the value of h theta 0 when x equal 1. Yani, okay, x theta x when x equal 2. Okay, so this also reflect to the value of x theta x when x equal 3. So that's reason why 0.5 times 1, 0.5 times 2, 0.5 times 3 over here. So this is the one remain, because what is the value of 1 to 3, guys? The real data of 1. Okay, so we just put it the way. So then we try to subtract all the things. 0.5 minus 1, 0.5 square is 1 minus 2 minus 1 square, and we have 0.58. Okay, so 0.58 is the value of j. Okay, so this one is 0.58. So then what is the value of theta 1? Theta 1 is 0.5. So then we plot here. So that's the reason why we do have this balls over here. Okay. Everyone clear about that? Are you guys can follow me right now? Is it okay?
Yes.
Okay, right. Okay, then we try to move the slope, the lines drastically as this line. Okay, right. So now the thing is similar. So how to do that? Is basically x0 is equal to the slope is 0 plus the intersection also 0, guys. So meaning this one is 0 times x, right? 0 times 2, 0 times, because of x equal 1. This one also x equal 2, this one also x equal 3. So 0 times 1 is 0, 0 times 2 is 0, 0 times 3 is 0 also, right? So 1, 2, 3 is fixed. Okay. So then we pull all the thing. So the answer is 2.35 for the y-axis. Okay, this one is 2.34. Okay. So then 0, 1 is 0. So that's the reason why it happened to be here. So now this, the function for theta equal 0. So we can see that over here, the behavior of the line is basically going to that kind of radian is going down, right? So as the minimum as possible. So the most minimum value that we have in this slope is basically happen here. Okay, so how we can bring this point to be as soon as possible to be the last one, to be the last, what we call it, j value, is the things that we need to be solved in the second problem. Okay, how we do it. Okay, so now, okay, based on this idea, I think we saw how to convert the x and y graph to j theta 1 and theta 1 graph, right? Okay, so we put it this way. So now, this one is theta 1, right? So this one is theta 1, right? You just follow my pens and over here. Okay, so what is the y value over here? J, right? Okay, so j theta 1 is basically this. Okay, so imagine that we need to have this and this. Okay, so what happened to this one, guys? Ni sudah. So why we need to have the 3 dimension? Okay, now I just put it this way. So the one that we discussed just now is this, right or wrong? So then we do have this, guys. If you see that dimension, you just imagine that you standing over here, you see through this one. So you might see this curve is basically producing this one, right? 2D dimension, so not 3D dimension. Okay? Can you get me?
Yes, yes.
Okay, so then just imagine that you see this graph to be, okay, so then I just put it. You just stood over here and see this graph. So then we will find that this graph could be this way, right? this dimension, but different is this one is J2. J1 theta 0, right? It's not theta 1 anymore. So see, this one is theta 1. So this one is theta 0. Okay. Okay. Then the combination between this one, J with theta 1 and J with theta 2 is basically the one that we see the things from the top, guys. Okay. So that's the reason why we can see this thing. Do you know about this one, guys? Ingat tak kita belajar pasal it's not this one. It's about 2D. We do have poles and zero in signal system. Ingat tak? Anyone remember about that? So the history behind this is basically, imagine that you have an arrow, guys. So, okay, an arrow. So this sign is basically, for us, the arrow is going in. So this arrow ni, echo dia kat belakang, guys. Dia pergi ke dalam. But this one, zero ni bukan truly zero, but the sign of 2D graph. So zero ni is exactly persembahkan ni, mata tajam anak panah. It's coming to us, ke muka kita. Okay, so that's the thing happen in maths in order to portray the things. Okay, similar as this, in order to portray this curving, so one suggestion is to have a blue. This one is called as a deep one, and this is the high face, meaning seharusnya dia begini, dia ke dalam, but it's not that way lah. So as you can see over here, this is blue, right? This region. So this is going to out a bit and out more and out more. So meaning this one is near to the out of the radius, means a bit high than things. Okay. So reflecting, this is high, this is a deep, and this one is going in. Okay. Kind of a hole inside. Kalau kita putarkan dia macam ni lah. Okay. Alright. So yes, alright. Let me erase from this slide first. Okay, alright. So now what we're gonna do is try to portray this thing. Okay, imagine that we have this line. Okay, so this one is 0, guys. Okay, so this one is 1. So what is theta 0, guys? Okay, I just repeat it again. Okay, x and 0. So what is this? And what is this? So we call it, in machine learning, we call it weight. We call it bias. But in order to discuss more about this, basically this is slope and intersect, right? So meanwhile, this one is basically referred to this intersection, guys. Sini. So that would be the similar one. Okay. Okay. So this value is basically the slope, or we call it tan theta lah. Okay. So that would be the idea of reflecting the dimension of x and y to be in j, theta 0 and theta 1. Okay, as we did discuss earlier, basically we try to portray this is a normal way to see the data, guys. So meaning, given a specification, we get the data. Okay, x and y. Berapa how the house is in size, so we can predict the price. How the distance the house from this capital, and we try to estimate the price. So the way it is, this is a normal common graph for us in order to see the increment and decrement per se. But this time around, it's not looking up directly to the data, but this one is just plotting the data in those features that what we said. So this one is feature. Okay, so feature to be plotted. in that particular graph. Okay, we try to change this x and y graph to j function. So this one, this time around, is not a real one data, but this one is just for the cost function. Oh my god. Okay, right. So the most important thing right here is to see that once we have the theta 0, and then we can knew that the theta 1 for this graph, right? So then we plot over here. Okay, so next one, if we have this particular graph, okay, so just imagine this one is the slope, okay? So slope is basically happen here. Okay, right here. And, sorry, intersection. So this slope is basically here. So we can have the tan theta over here. So this one is approximate this. Okay. So meanwhile, we can see that, okay, this point in our cost function and that point is basically dropping out so fast. Okay, from here. Remember? Kat sini kan? Okay. So the way it is, how we want to control the cost function not to be gradually goes down very fast. Okay, so meaning we try to have the graph meaning going up to here, down to here, down to here, down to here, and down to here. So that would be a good dropping. But the thing is, see that when happen, okay, I changed my mind to green right now. Happen when, say that we have this point, so we just go up to here, we just go to up here, we go to up to here, and we go up to here. So meaning to say that the point now is going up to here, going here, going here, going here. So this, meaning zigzag, it's not really good training purposes because what we call it overshooting. So meaning the behavior that we change this the graph is not really good for learning purposes. Okay, so that's what I'm saying. All right. So later on we see the real cases of that particular gradient. Where am I? Okay. Okay, this is the one that I mentioned earlier, gradient descent. So what is the gradient descent? Is an optimization algorithm, guys. Okay, which is mainly used to find the minimum of a function. So meanwhile, so that I say this now, so imagine that we have this thing. Okay? So we try to find the theta is going down to minimum 1 as it is. This one. Okay? Oh, sorry. This one. As the minimum as possible. Right? So that will be our targets for this gradient descent. Okay. So obviously, we need to have one point of start point, right? So we need to have this any. So let's say we put it any kind of value randomly. So we just start over there. So how it goes going down to the deep hole. Okay. So that would be the idea, to find the minimum. Okay. So in order to find the J minimum, is saying that we try to find the things to be going in, okay, as minimum as possible. Okay. So second thing to be considered after we set the value of theta 0 and theta 1 as to keep changing, guys. Okay, changing this to reduce cost. Okay, that's the reason why I mentioned earlier. So if we have this line, so we have this J, kan? So then we put it this line, we have different J. So we have this line, we have different J. So this J is basically reflecting to the graph this way. Actually this way. So meaning the graph is going down until find the minimum value, right? So that what is our purpose right now? Okay. So we find the minimum one. So in order to get that one, so we need to fix one start and keep reducing the value of theta 0 and theta 1. Okay. So choose initial value of theta and then update. Okay. Until we reach to the minimum value of the cost function. So meaning, maybe it could be started at this point, guys. And maybe it could be started at this point. And maybe it could be started, if we're lucky enough, we could start it from this point. Okay. So then the line itself will be going down as we go to the, sorry. Can I use red right now? Is it control? Going down. Okay. So because the blue is reflected to the deep one. So rather than red kat atas, hijau kat sini. So that would be the idea of having the minimum value of J function. So this one. So meaning the less. Okay. So to do that, basically we have kinds of equation to be fulfilled. So we need to initialize the theta. At first, repeat updating theta until the convergence. So what is the meaning of convergence, guys? Convergence means if we try to take a look at t and xt, so the t is going down. Okay. In Malay, they will call it memusat. So the opposite of convergence is divergence. Divergence is, in Malay, we call it mencapah. Okay. Okay. So simultaneously update. Okay. So in order to do this, we need to update this J. So J means the one that we discussed earlier. Okay. So in order to update J again and again, we need to multiply last J cost function. We need to manipulate this value, right? What we call it I just now. So this time around, it's not I anymore, because if we try to change theta again and again, basically this I is becoming to 0, 1, 2, 3 until D. Okay. So now we change this I to be J. Small j, because not this the last j ni, just j ni cost function, right? So that's what we have right now. So we try to manipulate the value of j from starting to the big numbers. Okay, by having the true j, the difference between this. Okay, so remember the one that we have in what they call it, okay, estimate minus actual. So that will be same thing. So basically this one is having the what they call it, learning, okay, rates. This one, how we learn the training data in order to have the difference gradient slope line for regression line number 1, line number 2, line number 3, depends on the learning rate. Okay, right. Okay, the function is alpha delta with delta j for this j, right? Okay, so this is the how we prove the equation for linear regression. So the moment that we have theta j equal theta j minus alpha delta j by j is basically this. Okay, sorry, this one. So what is this j? Is basically this one, right, guys? So remember, this one is half of half of MSE. So meaning MSE is this, okay, of estimate minus actual square and M. Okay, so this is I. So this is the limit function. Okay, so at the end we try to change it as it is, M. So jadilah begini yang tadi kita discuss panjang tu. Okay, this one somewhere. Okay, how we prove the equations. So then what we do is to change this one to be as this, because remember this one to be as this and that. Okay, so that what we call it, this one. Okay, so this is basically came down from this equation, meaning if we try to manipulate the graph, so means in the training time we have many training data, x1, y1, x2, y2, and so on and so forth, until kd. Okay. So then we try to expand it as it is. We try to change this one. Okay, this one is coming from the previous slide. So the reason why here is to use this. Okay, remember this. So we try to differentiate those things to be 2x, and these two will be going upstairs. So 1 to m2. So they will be cancelling, and will be this one, guys. Okay. So then we have this. So then again, we need, because we have this one differential, in order to differentiate this theta inside of this big bracket. So then we have this one. Okay. So then we do the differentiate between xj. So the things that we have in this function regarding to the theta here. What is the theta related function over here? Only this one. Yang ni tak terbatal. Okay. So we try to differentiate between xk, xk. So means we have only only this. Perbezaan terhadap this. So we have this. That's the reason why we remains this one at the back. Right? So that would be the for linear regression gradient descent. Okay. Okay, right. To simplify them, so take a look at this one. Okay, right. We don't have this. For example, just now as I mentioned, so you just pull this one. So approximate, it could be 800 lebih lah. So that's the thing that we are going up to here before 1000, and this is the slope. Slope is negative lah. Okay, so this one is negative slope. So then just imagine that we try to find the other one. So then this particular point of what we have j value cos, okay, is going in or lies going down. Okay, because of this one is the deep region. So while this one is the high one. Okay, so then it goes down. See, after, okay, so the moment that this point going into the deep, okay, take a look at the line, guys. Hold on. Okay, you just focus on this. Okay, you just focus on this line. Just focus on this line. Just focus on this line. So you just imagine that the line is basically from this to be this, kan? Dia menjurus kepada mendatar. Okay, then it will be going up again to find the best, the minimum cos sign in order to differentiate between this value and this data value. So that will be things related to that particular line. Okay. At the end, after we reach the minimum value of that j function, cos function kat bawah, okay. So this one is near to the mean. So this is basically the one that we try to find. Okay, this one is the minimum value because as I mentioned earlier, this one is like this. Yang ni adalah imagine that this is here. Here, it goes here, yang ni kalau kita petakan ke dalam. Okay, here. Okay. So then that will be going to the minimum one. Okay. As far as we change the slope a bit and a bit. Okay. So then we try to have this way. Okay. Going down. So the things that need to be avoided is basically overshooting. Okay, so meaning the idea of so just imagine this one just now. So it could be this way and goes to this way and go to this way and go to this way and that way. So that would be not good idea because the alpha is too large. Okay, so meaning the linear rate is large. It could be fail to get the converge one. Okay, so meaning to say that we try to have a good converge rather than overshooting. Okay, so to see if the gradient descent is working, print out the cos function for each iteration. Okay, so iteration meaning, what is iteration, guys, over here? Is it the I value? Is it the J value? Is it the D value? Which one? Okay, the value should decrease at each iteration. If it does not, adjust the learning rate. So meaning, in order to learn the process, the same goes to the neural network, guys. Okay. So when we try to learn it, so basically there will be parameter to be tuned up. So this one of those. Okay. To tune down the in order to get this a good gradient descending. Okay. To that particular minimum point of j theta. So okay, again I repeat my question. So what is the iteration value? Anyone? So what is iteration value? Okay, imagine that we have this. So what is so important? The iteration value. So which one? IJD. J. Okay. So the iteration value is basically reflected to this. The D is maximum. This one, guys. This one. It could be J, I, K, but the thing is, there must be a maximum value is for what we call over here in this context is D. Okay. So imagine that you start the calculation with J over here, and it could be K over here, I over here. Right? It depends on how you set things. Okay. Okay, thank you guys for watching NMZH channel. Hopefully you can get knowledge and benefit from the videos. Thank you so much. Assalamualaikum.